Hi, everybody. This is time for lab number 1 in astronomy. And so I wanted to give you a few hints and tricks, kind of an overview of how the lab is going to work. Our labs in astronomy, because you're doing them at home, are always going to involve a couple different things. They usually involve you building something. And sometimes I'm going to ask you to take some selfies and include those to prove that you actually built the things you're building. I promise they're going to be very low math, and so I'm going to send you for this lab to a website that will do the math for you. You just have to measure something and put a number in. I'm very often going to send you to another website where you're going to work with a simulation. So I'm going to show you how that works. And so let's take a tour of this, and I'm going to give you some hints and tricks. So I'm going to wander off to Canvas and let's get going. So you go to Astronomy Lab number 1, you click on this link and it will download the lab document. The very first part of this is I'm going to ask you to build a scale model of the solar system that is going to be accurate in size of the planets and accurate in distance between them. Now, the purpose is I want you to truly visualize how big and small things are in space. It's really vast distances between things. Before you start, I want to give you an idea of how large this whole thing is going to be. When I did this at home, I picked a tangerine for my son, and when I did the math, Jupiter ended up about the size of a head of a pin. And so on a rainy day, I took some pictures that's my fingers holding Jupiter. There's that head of a pin. And there's my husband way the heck down there by our barn holding the tangerine. And that is kind of accurate, the size and distance between Jupiter and the sun in my scale model. So how are you going to go about doing this? Well, here's what you're going to do. You're going to pick something for your son that you are going to use. Now, it's going to have to be something round. So I don't care if it's going to be a piece of bread, a rolled up ball of socks, a grape, whatever you've got floating around, but you're going to have to measure its diameter, which is that distance across. Somewhere in your home, you have a ruler. Trust me, most everybody has a ruler somewhere. And on one side of a ruler, there are inches. The other side, there are centimeters. Now, centimeters are the big numbers, and the tiny little squidges in between, those are millimeters. So pick one side or the other, write those down because you're going to need them. Then you're going to go to this website right here, and you can copy and paste that or click on the document online, and that will take you to, wait a minute, I've got all these loaded. There we go. That'll take you to this website, and you have to scroll down a little bit. Now, if you measured in inches, type the number of inches, the diameter of your sun in here. So I'm going to backspace and say I have a 1-inch ball. Then you hit calculate, and these are going to be the diameters of your pretend planets in inches. And this is going to be the scaled orbit radius in feet and inches. This is not just how many inches away they are. No. This is feet and inches. So if you have a 1-inch sun, Mercury is going to be 3 feet, a little over 5.5 inches away. If you have a 1-inch sun, Jupiter is going to be 46 feet, 7 inches away. Now, if you measured in millimeters, then the sun is 25 millimeters across and Jupiter is 46 feet or 14.199 meters away. So if you're going to use feet and inches, you have to include both of the feet and the inches. The reason I'm making a big deal out of this is in the past, I've had students who think they can just use the inches part. No, you've got to use feet and the inches part. So once you have that information, you copy that down in your own data table here, the diameter of your planet, and you only need the inches or the millimeters. Pick one measuring system or the other. You do not have to do both. And then copy down the distance, feet and inches or meters, onto your chart. Okay. Then using something squishy, bread, cereal, if you've got Play-Doh or clay, cool. And I want you to build planets that match the size of these. Now, they're not all going to be the same size. Jupiter is bigger than Mercury, and you're only going to build them, and I want you to build these so you get a visual idea, the representative size of these things compared to the sun. Then you're going to take a selfie that's going to include your fabulous face, your model of the sun, and your 5 inner planets, and you're going to upload this with your lab. Then you're going to build your scale model like I did with my tangerine and my husband, and you're going to build your scale model, and I want a picture of you, your sun, the model Jupiter, and at least your fingers included, so I can see that you've actually built this. The purpose, ladies and gentlemen, is I want you to really see and feel those distances in space. A little bit where I want you to take it further, and how far away would the next star, Proxima Centauri, be? Using this map, can you take that further and figure out where it is? And you're just going to have to draw on the map, so that's not that complicated. The next part of the lab is in the notes. We talked about naked eye observing, and we spent a lot of time in notes talking about different positions and zenith and the angles from one horizon to another. If you have not gone through the notes first, stop. Go through and watch the notes, then come back and do this. And then we used our hands to measure angles. Use that information about using your hands to measure angles, and I want you to go out and find some things in your yard or neighborhood. I want you to use your hands, and these indicators here stand in one spot, and standing in one spot, I want you to measure the width and the height of a tree that is close to you, the width and the height of a tree that is far away. So please stand in a spot so you can see both of those things. A car that is close to you and a car that is far away. And if the moon is visible, both the width and the height above the horizon. So how do you measure height above the horizon? Use some of these bigger angles and the information that we talked about up here. If the moon is not visible when you make your observations, then simply write down not visible at this time. The plane of the ecliptic. We spent a lot of time in notes this week talking about the plane of ecliptic. We are going to spend a lot of time talking about our ecliptic constellations. So it's important that you learn these. These are very much the superhighway of the sky. We use these as guideposts. So you need to know these, and you need to know them in order. So spend a little time making sure you understand this mnemonic device. A time gone, cowboys love viewing little stars, oh so cold and pretty. Which constellation is which? And then I'm going to send you off to a simulation at the University of Nebraska. We use lots of these simulations at the University of Nebraska. Now, here's a challenge. These simulations require something called Adobe Flash Player. Not all browsers like Adobe Flash Player. Google Chrome does not like Adobe Flash Player. Safari for Apple products does not always like Adobe Flash Player. So for example, when I am using Canvas, Canvas suggests you use Google Chrome. And what I personally have to do is I have to copy this entire link, and then I have to go to a different browser and open it in a different browser. Personally, if I'm in Chrome and I just click that, it won't open. So a couple things you can use is use the old-fashioned Internet Explorer, that blue E, to open it. Or every time it says allow Flash Player, allow it. You can go online and search how to install Flash Player, because honest to goodness, guys, we do this all the time in astronomy. So you got to get Adobe Flash Player on your computer. Or please contact the CVTC or e-learning specialists and have them help you get this software on your computer. This is something you will need, and you will need access to all semester long. Once you have that and you get to that website, it is going to look like this. And this is a really cool plane of the ecliptic simulator. Now, the Earth here, this little dot is the sun. And what's cool is you can take your mouse and you can move this around, but it shows where the sun is from our perspective on the Earth in different months. So if I go to, I don't know, the 1st of June, 1st of June, from the Earth's perspective, we see the sun sitting in the constellation Taurus. Now this is not the correct way the universe is set, because the sun, as you know, does not go around the Earth, but from our perspective, this is what we see. So we use these as milestones. We use these as observation points in our calendar year. And so if we say, I want to know mid-September, where do we observe the sun? The sun appears to be in the sky in, let's see, where is it? It's just entering into the constellation Virgo. So I ask you a collection of questions about different points in time, vernal equinox, different times of the year, different months of the year, and even your birthday. Now, in the olden days, of course, this was related to zodiac constellations, but zodiac constellations were done thousands and thousands of years ago. The stars have moved, the heavens have moved, the galaxy has moved, and so those are not exactly what they are today. As you go through this very first lab, please just fight your way through as much as you can. Please get help from the e-learning specialists, and if you have any questions along the way, shoot me an email, and I will be here to help you through. Don't forget to upload those 2 selfies with your lab. Have fun making that scale model. I think that's just kind of a hoot. And you have a grand week, and we'll be talking to you soon. Okay, bye-bye.